Hi, supposing u is a function of x and v is another function of x. So actually, I want to look at how to integrate the product of functions. But to actually prove the formula for that, you've actually got to start off with the formula for differentiating a product of functions. So as I say, so u is a function of x and so is v. So if you multiply them together and get the derivative of the whole thing, we know that the derivative of uv is u times the derivative of v with respect to x plus v times the derivative of du over dx. Now what we want to do is we want to make a substitution here. We want to say then that w is the derivative of dv by dx. Well, is the w is equal to dv by dx. So v then is then just the integral of w dx. So let's just, with that equation we've got for d by dx of uv, that's u dv by dx plus v by du by dx. What we need to do here, the next step is then to integrate both sides. So if you integrate the left-hand side, you've just got uv. Then you've got the integral of the product u dv by dx, and then the integral of the product v du by dx. So what we want to do is we want to then take the u dv by dx integral, put that on its own. So u dv by dx, then that's just the uv, subtract the integral of v times du by dx. Now if you substitute now that v is the integral of w dx and w is the derivative of dv by dx, that line then simplifies to just, it's the integral of uw times dx, and then instead of saying v is the integral of w, so then that's u, the integral of w by dx, and then the integral of the product. We actually swap the dv du by dx around, so put the du by dx first and then the v at the end. So the second term is the integral of du by dx times v. Now we substitute v with w dx, then integrate the whole thing dx. So then the integral, if you've got a product, if u is a function of x and w is another function of x, the integral of that is u times the integral of w dx, subtract the integral of the product of du by dx times the integral of w dx. Now, okay, so thanks for watching and goodbye.